Let's talk about the cotangent series, okay? And so what if we want to take the integral of cotangent of x dx? Well, again, just as in tangent, we're going to treat this as cosine of x over sine of x dx, because that's defined as cotangent. And essentially, what's happening is that I'm going to be able to do u sub. So if I set my u to be sine of x, then my derivative is actually cosine of x dx, which is exactly what we have. So this becomes the integral of 1 over u du. Okay, and we know the integral of this is just the natural log of the absolute value of u plus c. Well, what is our u? That happens to be sine of x, so this becomes natural log of sine of x plus c. So that's the integral of cotangent of x. Now, what about the integral of cotangent squared of x dx? Well, for this, I see an identity. And so if I look at this, well, cotangent squared of x is actually cosecant squared of x minus 1 dx. Okay. And so if I split my integral out, this becomes cosecant squared of x dx minus the integral of 1 dx. Okay. In this case, well, what's my integral of cosecant squared of x? What's my integral of cosecant squared of x? Well, we know it. Okay, we know the integral of 1 is just x. Okay, the integral of cosecant squared of x, well, that happens to be cotangent, right? So the integral of cosecant squared of x is actually cotangent. But remember, we got to attach our negative here. So this will be negative cotangent of x minus x plus c. Okay, and the reason why we attach our negative on here is because if I take the derivative of, without the negative, I take the derivative of cotangent of x, I get negative cosecant squared of x. Well, if I get a negative cosecant squared of x, if I have a negative out here, negative times a negative is a positive. And so that will give me my original integral back. So that's why it's very important that you attach this negative on here. And so this would be the integral. Now, what about cotangent q of x dx? Well, if I look at this, I'm just going to split it up. So this becomes the integral of cotangent squared of x times cotangent of x dx. That is the same thing. And now I see an identity. Okay, so if I look at this, this becomes the integral of cosecant squared of x minus 1 times cotangent of x dx. If I look at this, this becomes the integral of, I'm just going to split them up in 1, 2. So distributing my cotangent of x to both, this becomes the integral of cosecant squared of x times cotangent of x dx minus the integral of cotangent of x dx. And all I did was just distribute and split my integral up all in one step, okay? And so if I look at this now becomes a u substitution. So if I look at u to be cotangent of x, then my derivative, or du, is actually negative cosecant squared of x dx. We don't quite have that. We have the positive one. So if I divide by a negative on both sides, negative du now becomes cosecant squared of x dx, which is exactly what we have. And we know the integral of cotangent of x. That's just natural log of sine of x plus c. Okay. And so if I look at this, the integral now is going to be given by the integral sine of, for what was my u? Cotangent. So that's going to be u. And I got to attach my negative on here because I have a negative. Yeah, so this becomes negative du. So negative du replaces cosecant squared of x dx. Okay, so that's our negative du, and then our u replaces cotangent of x. And then we know this is the minus the natural log of the absolute value of sine of x plus c. Okay, because this is positive. So again, we already have our negative sign here, so negative times a positive is always a negative. So that's why this becomes negative natural log of sine of x plus c. And taking the integral of this one, we know our integration is going to give my negative 1/2. Or what was my u? Cotangent of x. So this becomes cotangent squared of x minus natural log of the absolute value of sine of x plus c. So that would be my integral of cotangent cube of x. Now what about cotangent to the fourth of x? Integral of cotangent to the fourth of x dx, okay? Well, I'm going to write this as cotangent squared of x times cotangent squared of x dx, okay? And so when I look at this, I actually could do some sort of identity. So this becomes the integral of cosecant squared of x minus 1. And we're going to multiply that by cotangent squared of x, the original one out here. And so if I look at this, when I distribute, this now becomes the integral of cosecant squared of x times cotangent squared of x minus cotangent squared of x dx, okay? And all I did was just distribute this all inside. Okay, and so when I look at this, I'm going to split my integrals up, but when I look at this from a standpoint, I could definitely see that I have some sort of u substitution going on for this one. Okay, we already know the integral of cotangent squared of x, okay? We already know the integral of that, and we already said it was negative cotangent of x minus x plus c. Okay, and so when I look at this, I'm going to split my integral up. So this, the equal sign now becomes the integral of cosecant squared of x times cotangent squared of x dx minus the integral of cotangent squared of x dx. Okay, for this one, if I set my u to be cotangent of x, then my du is actually negative cosecant squared of x dx. Again, I don't have a negative, so if I divide on both sides, my negative du now becomes cosecant squared of x dx. Okay, so negative du actually substitute for these two, and we know u is this cotangent of x, but it's squared. So this now becomes u squared. We have our negative here, and we have our du here. So that takes care of that. And we know this is negative. Well, what was the integral of cotangent squared of x? That happens to be negative cotangent of x minus x plus c. Okay, so notice I have my original negative here, and the integral of cotangent squared of x is actually negative cotangent of x minus x plus c. Okay, so if I look here, it's negative cotangent of x minus x plus c. And so we got a distributor and negative. So that's a very important point to note. So integral now is going to be given by, what's the integral of u squared? That's just 1/3 u to the third. So this becomes negative 1/3 because we have a negative outside here. But what was my u? That happens to be cotangent of x. So this will be cotangent q of x plus cotangent of x plus x plus c. So all I did was just distribute my negative to my integral of cotangent squared of x, which I didn't bother to do since we already did it. Okay, and that's the cotangent series.